Let us move on towards our next paragraph of Clayden book, Organic Chemistry and the Periodic Table. All the compounds we have shown you. So up till now, whatever compounds have been shown to you in the previous 40 lectures or so, all the compounds which have been shown to you are built up on hydrocarbon. Okay, they are built up on hydrocarbon skeleton. That is carbon and hydrogen skeleton. Carbon and hydrogen make the skeleton of these organic compounds, and it is true for most of the organic compounds. Okay, the basic skeleton is made up of carbon and hydrogen, that is hydrocarbon, in most of the organic compounds. That is the definition of organic compound, that the skeleton must be made out of carbon and hydrogen. Most have oxygen or nitrogen as well. Okay, so most of them, along with carbon and hydrogen, they also have oxygen, and also have nitrogen sometimes. Okay, some of them have sulfur also, and some of them have phosphorus also. Some of them have sulfur also, and some of them also have phosphorus, and many of them also have halogens. Many of them also have halogens like fluorine, chlorine, bromine, and iodine. Do not think about astatine. Let me tell you, do not think about astatine, because astatine is a radioactive element. Astatine is a radioactive element, so do not think regarding that. Okay. So halogens are there: fluorine, chlorine, bromine, iodine. Do not think about astatine, because many students also think about astatine. So that's why I specifically told that do not think regarding astatine, because astatine is a radioactive element and its chemistry study is limited. Okay, so it is not usually studied in organic chemistry. So only 4 halogens are studied: fluorine, chlorine, bromine, and iodine. Okay, these are the main elements of organic chemistry. These are what? These are main elements. What are the main elements? From this paragraph, we can say that carbon, hydrogen, nitrogen, oxygen, okay, fluorine, chlorine, bromine, iodine, sulfur, and phosphorus. These are what? These are main elements of organic chemistry. You should remember this particular fact. And also, when you study organic chemistry in detail later on, you will automatically come to know that these are the elements which are most most commonly occurring elements in organic chemistry. Okay, so carbon is there, hydrogen is there, these are most common. Then nitrogen is there, then oxygen is there, then fluorine is there, chlorine is there, bromine is there, iodine is there, sulfur is there, and phosphorus is there. Okay, so these are the main elements of organic chemistry. Remember this fact. But organic chemistry is not related, or not only limited. Organic chemistry is not just limited to these elements. It is beyond these elements as well. But those elements are quite less frequently occurring. Okay, the elements other than these elements, the elements which are other than these elements, they are less commonly occurring. Less commonly occurring. That is, they have less frequency amongst carbon compounds. They have less frequency amongst carbon compound. Other than these, those elements which are other than these have less frequency in organic compound, but those are also found sometimes. Okay, although they have less frequency, but those are also found sometimes. But organic chemistry has also been benefited from the exploration of, okay, rest of the periodic table. So the periodic table right now has 120 elements. Okay, till Oganesson. Okay, till Oganesson we have the elements. Okay, and this is as of 2025. Later on many new elements might be discovered, but this is as of 2025. I am talking about 2025, that is the world at present. If this video is being viewed in some other year, future year, then there might be one or two more elements which have been discovered after Oganesson. But right now, when I am making this video in 2025, only 120 only elements up to the atomic number 120, Oganesson, up to there only the elements have been discovered. Okay, after this Oganesson, the elements have not been discovered yet as of 2025. Okay, so the periodic table contains elements starting from atomic number 1, that is hydrogen, up to atomic number 120, that is Oganesson. Okay, so the organic chemistry has also been benefited from exploration of the rest of the periodic table, because the elements which are other than these elements, those form the rest of the periodic table. These compounds occupy specific positions in the periodic table, right? These elements occupy specific position in periodic table, But elements which are other than these elements, those also are there in the periodic table, which occupy other space in the periodic table other than these elements. Okay, so the author is referring to them as the rest of the periodic table. So the organic chemistry has also been benefited from the exploration of the rest of the periodic table. It is as if that it is taking over the other branches of chemistry. Okay, so it is saying that organic chemistry is taking over other branches of chemistry slowly and slowly, because more and more carbon compounds are being discovered which contain elements other than these common elements. Okay, the organic compounds which contain elements other than these, okay, not these but other elements as compared to these, okay, other than these elements, those compounds are also being discovered day by day. So organic chemistry is slowly getting merged, okay, getting overlapped. It is getting overlapped with what? It is getting overlapped with inorganic chemistry, physical chemistry, pharmaceutical chemistry, okay, atmospheric chemistry, analytical chemistry, okay. So with all those branches of chemistry, that is the other branches of chemistry, the organic chemistry is getting influenced by those branches of chemistry, because new other elements are also being discovered in organic compounds. Okay, in organic compounds other elements are also being discovered. Other elements means elements other than these common elements, those are also being discovered in the organic compounds. Okay, so organic chemistry is getting influenced by inorganic, physical, atmospheric and other type of chemistries, pharmaceutical chemistry, medicinal chemistry, polymer chemistry. Okay, so organic chemistry is getting overlapped or influenced by all those branches of chemistry. Okay, some would say take over bid for. What does it mean by take over bid for? To take over someone else's business. That is the meaning of take over bid. Okay, so in organic chemistry, with each passing year, we are studying more and more other type of compounds, okay, which were never studied before. For example, organometallic chemistry is a relatively modern branch of chemistry. Organometallic chemistry is a relatively modern branch of chemistry, and metals have even been encountered in organic compounds. Metals have been discovered in organic compound as well. That's how organometallic chemistry's birth took place. Okay, so metals when were discovered in organic compounds, it led to the birth of organometallic chemistry. So this is the thing. The organic chemistry of silicon, boron, lithium. Okay, the organic chemistry of silicon, boron, lithium, tin, copper, zinc and palladium. Okay, so the organic chemistry of these compounds, 1, 2, 3, 4, 5, 6 and 7 compounds, silicon, boron, lithium, tin, copper, zinc and palladium. Organic chemistry of these 7 compounds has been particularly well studied. It has been well studied, okay, and these elements are common constituents of organic reagents used in the laboratory. They are common constituents of organic reagents which are used in the laboratory. Okay, so many organic reagents are used in the laboratory. So in those organic reagents, these metallic elements, not all of these are metal. Silicon is a non-metal. Okay, boron is also a non-metal. Lithium is a metal. Tin is a metal. Copper is a metal. Zinc is a metal, and palladium is also a metal. Silicon and boron are non-metal. So out of these 7, 2 are non-metal and 5 are metals. Okay, so they have been also studied, well studied in organic chemistry, because of forming compounds containing carbon and hydrogen. Okay, and along with that, these elements are also present along with carbon and hydrogen in that compound. Okay, so the organic chemistry of these compounds has been particularly well studied, and these compounds are common constituents of organic reagents which are used in everyday laboratory. Okay, so organic reagents often contain silicon, often contain boron, often contain lithium, often contain tin, often contain copper, often contain zinc, and often also contain palladium, many of the reagents. Okay, you will meet many of them throughout this book. So because it is only unit 1 of this book going on right now, so many of the compounds which we are discussing, okay, which we are talking about right now, haven't yet been discussed. Okay, many of the compounds about which we are talking right now haven't yet been discussed, but we will discuss them as we move further in this book. So it is saying that we will meet many of these compounds containing these 7 elements and other more elements also. Perhaps beyond these 7 elements also, some more elements also might be there, additional. Okay, so we will encounter them as we move ahead in this book. Okay, So you will see many of them throughout this book. So butyllithium. Okay, butyllithium. The structure is like this. This is butyllithium, Buli, meth, eth, prop, and bud. 4 carbon chain. So that's why butyl group, and it is attached to lithium. So it is called as butyllithium. Okay. So this is the compound. Then trimethylsilyl chloride. So there are 3 methyl groups, 1, 2, and 3. That's why trimethyl. Silicon is there. That's why silyl. And chlorine group is there. That's why chloride. So trimethylsilyl chloride. Okay. Then tributyltin hydride. So 3 butyl groups, 1, 2, and 3. 3 butyl groups, 1 tin atom in the center. Okay. And 1 hydrogen atom attached to the tin. So tributyltin hydride. Okay. Tributyltin hydride. So Bu3SNH. The symbol of tin is SN. The symbol of tin is SN from the Latin name stannum. Okay, derived from Latin name stannum. So tributyltin hydride. Then what else do we have? We have diethylzinc. Okay, so this is one ethyl group over here. This is another ethyl group over here. Zinc is there at the center. So diethyl, 2 ethyl groups. So diethyl zinc, Et2Zn, diethyl zinc, meth. So diethyl, two ethyl groups are there attached to the zinc. So diethyl zinc. Lithium dimethylcuprate. Okay, lithium Li positive ion is there, Cu negative ion is there, and this entire entity is negative, contains negative 1 charge. Okay. So 2 methyl groups, CH3CH3, 2 methyl groups are attached to this carbon which contains negative charge, and this lithium contains positive charge. Okay. So Me2Culi, lithium dimethylcuprate. This particular thing is dimethylcuprate. Okay. This entire entity is dimethylcuprate. Okay. So lithium is attached to it. So lithium dimethylcuprate. Okay. Lithium dimethylcuprate. So this is another example, right? So these are some of the example of organic compounds which are relatively new, have been obtained later on, and contain other elements. Okay, elements other than these elements. They contain elements other than these elements. Okay, so those have also been discovered, and those also we are going to study as we move further in this book. Okay, so this is all about today's class. Now one end screen will appear over here. Click on that end screen and watch the entire Clayden book playlist. Okay, so this is the thing. Thank you very much.